Oh no! Oh, there I am. I'm like, wait, hang on a minute. Hello, everybody! Oh, it's my Porsche. Hello. So, I have something a little unusual that I hinted towards last time. Granted, I was less sick last time. I've kind of caught a little bit of a light cold, so I apologize for the sniffles and coughs that we're going to hear this evening. I'm doing my best here. I mentioned that with all the stuff we had been doing with the 30 Days Lost in Space franchise, we are going to do more of that to finish that out. But in the background, I was working on my first custom project to see if I at least understood the program I was working with to be able to make my own custom thing. So, with this being June, and it being the LGB with all the other letters style of doing things, which I am blanking on the rest of that. Hang on, I'm gonna pull this up because I need to get it right. Come on, do the thing. I'm so bad with acronyms. Yes, the LGBTQIA2S+. Interesting, it changed since the last time. But regardless, this is the month of celebrating our differences that also bring us together. I came up with the idea of this particular project. So what is this that I'm referring to? I thought it'd be kind of cool to put together a custom project board that would allow you to cycle through 3 different pronouns: he, she, and they. I know there are spark pronouns and others, but honestly, I needed it to fit on a board, and I also really wanted it to run via battery. The XE and XER or IR, I didn't include into this. I felt this was inclusive enough, but also not power hungry enough that it would require multiple batteries. I'm getting away with a single 18650. But I want to see what I could do from start to finish. So let me show you what I've done to get us to this point from behind the scenes. And then we're going to build it. Now, a little bit of disclosure. I had discovered that I did make a mistake, and the mistake went to production. Thankfully, though, I screwed up in a way that it will still work. But I have to install a couple of the components backwards to make them function as intended. That does not hinder the project. It does not make the project unsafe. It just simply means that the labels on the board of where the positive and negative go are backwards, but only for 2 of the letters. But I'm gonna get there. So, let me get us over to our friendly neighborhood breadboarding software. That one. Alright, cool story. Alright, let's dig into this. So, first things first, actually, you know what? Here, hang on, before I even do that much, let me open up Paint. Because I actually want to show you how I even got to this before I even got to the schematic. Because this is one of those really dumb things that I looked at this and I thought, okay, all right, I want to include, I'm going to freewheel this with my mouse because I don't know where my trackpad is right now. I want the brush. All right, there we go. Okay, all right, cool. So I want to include the different words of he, she, and they, right? So first impressions, when we look at the 3 pronouns, we have letters that share. He fits inside of she. He also fits inside of they. So if I just lay those out in a way that I could just turn on and off the respective letters I want and just lay them all out, there's going to be a tiny bit of an awkward spacing, but it'll still work, right? So then what my thought process was is I grabbed my brush, right? I literally did this on a sticky note that I don't know where I put. I started writing out the letters. Right, so I had he, and then of course we already know that if I just had an S in front of he, we get she. But for they, right, then I was like, I'm like, all right, hang on, let me back up for a minute then. If I make a little bit more space then between the S, the H, and the E, excuse me, howdy Pine, welcome on in. I figured, okay, I could just wedge in the extra letters I need and put the T over here and the Y on the end. So then you kind of get this kind of bit of a goofy looking mash of letters.
Bob, can I get a glass of water?
I appreciate that. Oh my god, I am dying so hard with my sinuses right now. That is some good tea. It's hot tea. It's amazing. There's no honey in it. It's just hot tea because I'm trying not to die. I take a pretty good job of it right now. I'm just stuffy at the moment. I'm hoping we're just gonna immediately get better and we won't do any more of this cold thing. I don't know, man. It seems like it's that time of the year, but you know, it's like just fighting off the allergies and the colds and just, you know, life in general. Just be like, we fight. We go win. But yeah, so then we got this gobbledygook of letters, right? But if I can individually control with 3 separate switches the letters I want to toggle, well then there you go. That's the project. So I ran with that, right? So then the next side of things, I'm not going to show you the math I did because honestly I don't have that prepared in a way that it like makes reasonable sense. But the TLDR version of it is that red LEDs are 2 volts DC, green and white and blue are all 3.3. If we use Ohm's law, that means that we need, oh, you better believe it, yeah, math. The worst kind. The kind you have to figure out on your own. My goodness. We need to protect the LEDs because I'm gonna put them in parallel. I've talked a little bit about parallel circuits versus series circuits, but I'm running this off of a single battery that provides 3.7 volts DC, which means that if I put multiple LEDs in series where they're all wired together, like old school Christmas lights, then the power requirement is gonna immediately go over the limit. Because if I do that, the power requirements, if I say I have 5 red LEDs, well those are 2 volts times 5 LEDs, that requires 10 volts of electricity at like 0.2 amps or something, or 0.002. It's something that's super small in amperage, right? That also saves you in resistors because you only need 1 resistor to protect all those LEDs from accidentally drawing too much current. We have talked about the protection of the circuits in the 30 Days of Space by adding a 220 ohm resistor to protect our single LED that's hooked up to our Arduino, right? Or our hero board, as it's called in the exercises. But when you stitch multiple of them together in series, what gets you 1 resistor requires a much higher voltage draw. Now, if you just do a single resistor per LED, then your power requirement continuously stays at, in this case for the red ones, 2 volts, and then you put in a resistor to consume the rest of the voltage from the battery, which is 3.7. Oh, car speakers, Pine. I feel that pain. Oh, I do not loathe you. That speaker math is its own thing in and out, right? And also gauging for an amplifier that can also produce enough oomph to fire the speakers in a way that doesn't damage the amp, doesn't damage the speakers, doesn't fry the car wiring. All those things need to be considered. And if your wires are not thick enough, you're gonna melt something. That was also something else that tied into this entire disaster. Excuse me while I blow my nose. Apologize if the mic could pick up on that, but I'm again trying not to die. Oh yeah, theory is definitely different than the application. I think the one thing that really I thought over with doing this project is that some of the components you're going to see are well over the rated of what I needed for this. But that was because when I was looking through the catalog for the parts, There's millions of parts, and I found one that I knew that would fit, but would be slightly beefier than what I would have required. If I were to do this project again, other than fixing the mistake I made in the schematic, I would order smaller resistors. I don't need the ones that I got. They're overkill for what I require. But with that, yeah, parallel. So all the LEDs are in parallel, which means that if I've got 3.7 volts coming from the battery and a red LED uses 2 volts, I need to consume 1.7 volts to prevent the LED from getting too much power and going away. You know, the whole shorting out and going poof kind of thing. So the math on that equated to 100 ohms of resistance to consume that 1.7 volts. And in the case of the green and white LEDs that I used, those are 3.3 per LED. So if we take our battery and subtract 3.3, that gets us 0.4 volts, just under half. Which means we only need 47 ohms of resistance to consume the remainder of that, which again evens the circuit out, protects the LED. So if we add up all the LEDs that I have here that go across the entire project board, if we turn them all on at once, which, as we can clearly tell from what I have up on the screen here, doesn't really equate to anything that makes logical sense. It draws just around an amp. So that means I need a battery that's capable of supplying at least that amount of power for a decent amount of time. Full disclosure, I did not do as much research on the capacity of the 18650 battery as I should have, and that's on me. But I also don't have enough confidence to put more than one of those batteries into a project without doing further research on protecting the circuit and the battery from failure. I did add some security into the circuit with some diodes, and I'll show you that, even though technically the whole project is mostly diodes, because LEDs are light emitting ones, but that's besides the point. Let me show you this disaster I got myself into. Do not need to save that because I'm kind of done looking at that. Okay, so quick overview. Exactly, Pyro, exactly. This is the overview of the schematic. So everything that is in this design is all this stuff in this area. So let me briefly show you what we got going on here. We've got our path to ground that's chilling out right here, right? And that connects to our battery. We only have a single battery. And it's going to hold an 18650, which is why if you look at the part number down here, it's an 18650 dash, and then the rest of the part number that actually holds the battery in on the board. That then gets connected to our 3 dip switch package that then connects to 3 separate diodes that then allow us to control the letters. So the H and the E, I actually spelled out up here. If you look at it, squint real hard, you know, maybe stand 10 feet away from your phone, you can maybe read it. I don't know. It's kind of hard to tell. I just placed it for my own visual purposes. And then for the S, we're doing red. I did green LEDs for H and E. And then for the T and Y, they, I did white because they is more gender neutral. So I figured what's better than white? Just that's the best. My only other option was yellow or blue, and I felt like white was the most ambiguous of the colors. I don't know. That's what we went with. So, with that rocking and rolling, I'm going to show you what the schematic looks like, and then I'm going to show you where the mistakes came in. I did something that I used a tool, and I thought I double checked its work. But turns out I missed a mistake that jacked up the center of my board. Now, knowing what I do about electronics, LEDs are light emitting diodes, right? So that's why this these 2 lines indicate light is emitted from this diode. Because if we take a look at the diodes that are up here, there's no little lines up here, which just indicate these diodes just allow electricity to pass in one direction and only forward. Electricity will not flow backwards through this circuit with these here, which means that if I'm stupid and I put the battery in backwards, we're not going to make smoke. The circuit won't work because I have these protecting the battery. Now, I say that And I say that they're also kind of extra and not necessarily needed because what are LEDs? LEDs are diodes, but they give off a light, which means that if I put the battery in backwards, the first thing it's going to hit, because the resistor is on the positive side, normally speaking, is the LED, which is going to stop electricity from passing, which means this entire project is secure from reverse voltage on accident. Have I tested this? No, because I don't want to put the battery in backwards. But I have done all the things to make sure that if it does happen, nothing bad happens. I probably am going to test it, but I'm going to do it outside somewhere near something that won't be flammable. I have no reason to believe that this is not correct from all the research I've done, but I also like to test use cases that could potentially end in catastrophic failure in a controlled environment. And in my current situation is not that. So we're just simply not going to do that. Just like a fire demonstration on how to use a fire extinguisher. You don't do it in your house. You do it outside. Particularly usually in the middle of a field with stuff that does not catch on fire. Okay, so now that we have that out of the way, we can see here the resistors, their ohmage rating. Which is why you'll see that the red LEDs are the only ones that have the 100 ohm resistance, because these use 2 volts, when the white and green use 3.3. I'm going to show you the schematic next. So, when you're ordering a PCB board, you have to tell the manufacturer where all the traces go on your project. When you first generate this particular layout in all these cool lines that I've got going on here, there is no traces. The traces are the red and blue blue lines. A red one indicates it's a trace on the top of the board. A blue one means it's on the bottom of the board. That's how you can get away with wires that have to go and they overlap each other, right? I could see that this red wire goes over top of these 2 blue, but there's no short here because the board is in layers. This is a 2-layer board. There's a layer on the top and a layer on the bottom. Now, granted, there's multiple layers involved here. There's layer 1 through, what are we here? 1 through, I want to say 1 through 10, but that's technically not true. Oh, there's 2 usable layers, but it's like 10 layers thick. Because you've got the top layer. The silk screen layer is where all the pretty graphics show up on the board, which is like where it says the LED and its number. And if I actually toggle the silk screen layer off, we can no longer see the components phrases. They're going to get written on the board. Cool thing about this is you can add your own graphics and text on this layer, and it will be printed on your board. I didn't do that for this because I was experimenting with it, wasn't necessarily sure if it was going to be stream appropriate or whether it was going to work at all. So I didn't bother doing anything other than the components. Now, if I toggle the top layer, that turns off all the positive leads. And if I toggle the bottom layer, that hides all the negative leads. Let me show you where the mistake came into all this. I used a function called the auto router. The auto router takes your schematic, you lay out the components where you want them, and when you click the auto route button, it's supposed to connect all the traces to all the different components in a logical fashion that electrically functions and is safe in its own right based on the criteria you provide the tool. As you'll notice, the primary trace that provides the voltage from the battery to the rest of the project is thicker than the rest of these. The auto router didn't do that. I did. I wanted that trace to be thicker because we're handling about approximately an amp's worth of electricity through this single trace, which means that it's going to need to pass a lot of voltage. And after following some calculators on the internet, I came up with a trace thickness of, I believe, 20. That's what I came up with here. I don't see that here in this selection. Oh, I'm looking at the wrong component. There we go. Line width, 20 mil. Okay, so that's what I came up with for the thickness based on the research I did from the internet. It's very much a science on how thick the traces need to be, and I am far from an expert. I just did a decent amount of research in a decent amount of time. I would say a short amount of time, but it did take me a while to get this from the sticky note into the computer and all the things we're seeing here today. Let me show you where the mistake happened, though. Now, I don't know if that means I simply misused the tool or if the tool made the mistake. I don't know, because from the manufacturer that makes this software, they say that the auto route is a really cool function, and some people on the internet also would agree. There's also a lot of other people on the internet would indicate you should not trust the auto router because it can make dumb mistakes, or it can also do things that don't look good. But I mean, I'm of the mind that if it's electrically connected and it's electrically safe, I kind of don't care what the spaghetti looks like on the board, because at the end of the day, I'm not looking at it. So cleanliness of the traces, I would like it to work in PC. So let me show you actually what one of the good traces looks like, and then you'll be able to compare and see what I'm talking about. Okay, here's LED number 25. There is the ground, right? And that's the blue line, right? And that goes to one of the grounding rails. Great, that's exactly where it's supposed to go. If we take a look at our positive, that comes up here and connects to its respective resistor, number 25, that provides the positive voltage that's supplied from this rail right here. So the 3.7 volts comes in here, it goes across the resistor, and then provides the respective voltage on the positive side of this LED, hits the ground, and goes back to the battery, and the process starts over again, which is the way it's supposed to be wired. Positive to positive, negative to negative. That means electricity will flow. Let me show you the mistake. Okay, so this is LED number 1, which is a part of the H in he. There is our negative rail, and that connects to the resistor. And on the other end of the resistor is the 3.37 volts, which means 3 volts, 3.7 volts is, well, technically dropped down because it went through the resistor, is going to the negative side of our LED, and then the positive side was connected to ground. The trace is backwards. It functions, and there's nothing wrong with, electrically speaking, but that means the silk screen is printed backwards. The positive is on this side, and the negative is on this side. I didn't catch this, and I don't know why, but obviously, as you can see here, this is kind of loud by the amount of things that are here. And that mistake happened because I used the auto route function, and I thought I had double checked the work. I looked at this project probably about 3 or 4 times before I sent it for production. I missed it. And then I also didn't see anything in the logs or the software in general barking at me that I made a mistake. I don't know what level of checking this program does for that kind of stuff. I would imagine not really. But what I find interesting is that in the schematic, I told it exactly what piece is supposed to be connected to where, and if we follow this, there's ground. So I don't really know how the auto trace managed to get me to this place. I also don't know if it was just operator failure, if I had I misunderstood the menu. This is involved. It's not easy, which is also why a lot of what I did here that I've expressed over the last 20 minutes I did off camera, because I want to do a project together with the community from start to finish, but I need to understand the small semantics that make up getting a project from beginning to end before I do it here. Because it's way less entertaining if I sit here quietly for 30 minutes not saying anything because I don't know what I'm doing. I wanted to make something preparable. So, with that, one more thing I'm going to show you before we actually start building this is the 3D render. Something I love about this is that you can 3D render what the project is going to look like before you order the parts. Or excuse me, before you order the board. Because when you submit the order, all you're getting is this big blue board, in this case I ordered the green one, of the traces in all the holes. The components you have to buy separately or pay for their service to assemble the board on your behalf. That's the thing they offer, but I wanted to build this myself because, of course, this is fun. This is so involved. This is the most involved I've ever gotten with electronics before, and I wanted to be the one to put it together. So of course I ordered just the boards. But we can see here, there's our battery connector, there's all of our LEDs, and then our letters, and then our switch pack up here that allows us to toggle the different circuits. So if we toggle number 1, that turns on the H and E and he. You toggle switch number 2, that lights up the S and she, giving you she. Toggle off 2, toggle on 3, that gives you they. So that's how the project is broken out. After I submitted the order and got the parts, I did a trial run off camera and then discovered the mistake. Thankfully, because LEDs are diodes, nothing bad happened when I went to assemble it, because it just didn't let electricity flow and it didn't light up, which initially made me think I completely screwed up the project or that I got a bad production board. No, it was a mistake that I sent the production that I simply didn't catch. So it's very important before doing that to make sure you verified your work. And the next time I do one of these, I'm going to lay out every trace myself, because then I know that everything is where it's supposed to be, and then I can, double check my own work instead of trusting another toaster to do it on my behalf. It just makes the most sense to me. Okay, so with that out of the way, we're gonna do some stuff. Okay, let me get us going here. Give me a second. I gotta bring chat over here with me. Do. Okay. All right. Chat with me. Oh, we have a follow. Hello, Draco. Hello, Draco. Thank you for the follow. I am Tekken41. I do silly things on the internet and play games in my spare time. If we're not doing something crazy like this. This is the first time I'm doing something crazy like this. We'll walk about it. Okay, so put that where it needs to be. So the iron went to sleep. That's okay. That's alright. It'll wake up. Okay. Alright, excellent. We are now over here, and now we're gonna cook some stuff up here. So, as I had expressed, the board I had ordered is here. Now, something that I can show you. Well, actually, can I do that right now? No, I will need power and components before I can show you that. That's okay. Here is our project board. So we can see here that it's just a PCB. We can see all the traces that happen here. And this is where we're going to lay all of our components to get something that looks like our project that we saw in the 3D render. So we are going to start. We're going to start with the battery module, because that one's a bit of a hefty one to stick on here. I'm purposely going to keep the camera zoomed out. If you would like to see something closer up, please ask. Because if I zoom the camera in, I think I'm going to be a little too close, and you're just going to see not a whole lot. Okay. So first things first, our component holder has this little nub of plastic that actually meets out with a knockup that's on the board. So if we look right, there's that little hole right there to indicate that is the top of the battery holder, which we're going to meet up like so. And then we're going to take our roll of lead-free solder wire that is 0.7% copper and 99.3% tin. Put everything together. Now, this soldering iron is set to the temperature of 650 degrees Fahrenheit. It is hot. So I'm not going to touch it. As we see down here, there's this nice bird mark in my placemat because it touched it. And I'm glad it was the placemat and not me. Because I can express to you right now, that would have hurt. And that's not something we're looking to do. That I can promise you. Okay, so this next part is going to be a little tough because this is a really big component. And this is going to require a ton of solder to get this to stay in place. Everything else is a lot easier because once you kind of pop it in place, then it kind of will just stay put. All right, cool. That is one pad ready to rock and roll. Okay, so now that this is secure, we can see here that we're good to go. We're gonna do the other side. The one thing that's nice is that you actually can check your work as you move along with the multimeter, which is I'm going to show you after we get this secure. Oh, my sponge had dried up. Just a moment. I'm going to need to wet this. So in between touching the soldering iron to something, I've got a sponge here, and it's designed so that you can wipe the soldering iron tip off. Because as you move about, there's the components, and then there's also the different things that build up over time, whether that's flux, pieces of plastic, other random things that should not be connected to your other stuff. And then you just kind of wipe off the iron as you go along. That keeps everything content. Okay, now that we have a sponge that's more spongy, that's better. I felt that and I'm like, that definitely dried up. All right, cool. There we go. All right, now I can actually wipe the iron off. That's much better. Okay, so as we have here, we have our multimeter. That's interesting. Why do you think you're shorted? Well, that's not good. Well, that's the first time I've ever had it do that. Huh. Well, that's a shame. I'm not going to be able to show you that then. Let me set this to voltage for a minute. Hang on, let me let me see if at least some of the functions are still working. Let's see. That's interesting. I'm not getting any voltage on this battery. That's a good battery. I mean, I suppose it's possible that the batteries are low, that it's misbehaving, but that's very unusual. What if I take the probes out? Huh. Well, that's not particularly good. Alright, give me a moment. I'm going to do a quick battery change here. Because of course, why would Alright, we're just going to ignore the fact of the things I was going to show you with that, because it decided to just die in the moment. Apologies for that, but it's still going to work out all the same. That just simply means I'm going to go buy a new multimeter in town tomorrow. Listen, if you want to get into live streaming, just anticipate things just not working. If you just assume nothing's going to work, then you won't be disappointed. Because as someone who streams, it just happens. It's fine. I know I've got an extra one laying around here somewhere, but to be completely honest with you, I don't really want to waste the time looking for it. This is not the time nor place to go looking for something that I don't quite know where it is. But that's alright. Alright, well, with that out of the way, we have our battery holder in place. I was going to show you the continuity the rest of the board, but we're going to omit that fact. That's okay. But what we are going to do is I have a paper copy of that schematic so that I know which particular resistors go in which holes. And this project is pretty straightforward. The S are in red LEDs, the T and Y are in white, and the H and E are in green with the polarities of LEDs in reverse because of the mistake when I submitted the order. Which means that we only have 100 ohm resistors for 9 of the LEDs, and the rest of them on this board are the 47 ohms. So since we have a bit of an oddball, we're going to start with that. Because if you get through the oddballs first, then it's pretty easy to not mess up the rest. Or at least one would hope. Okay, so we need a total of 9 of these little goobers. And this is how they come, by the way, when you order them. They're in this like giant roll. Now, to be completely transparent, they come in a big roll because I ordered like a lot of 100 of them. But when you order any more than just a single, that's how they come together. And that bizarre looking wrapping. Now, the bag that I'm putting these back into is labeled with what they are, but if I didn't know that offhand, by just the size of them, I would figure they're either 1 watt or 2 watt resistors. And the color tells you the resistance. The colored bands on the actual LED is what makes up the resistance. That's how you can tell what this is if you didn't have the neat little anti-static bag indicating what you're actually playing with. And if I remember correctly, these all go in this upper row, if I believe that I've got that correct. So these need to go through 24 through 32. So we got... it's 29. Yes, okay, so it is that whole top row. Alright, good. That makes things pretty easy. So, to install these, resistors do not have a polarity, which means when you add one to a circuit, it does not matter which way you put it in the board. Now, for cosmetic purposes, we're going to install them all facing the same way, so that all the colors line up in the same fashion. Now, these are a little bit of a cheat because there's 2 brown on the outer edge. Because of that, it indicates the which side is the top, which is the tolerance, and then the 3 colors in the middle are the actual capacity, or excuse me, the resistance of said item. So to install it, we're going to line it up like that, and we're going to push. And that pushes it through the board, and that seats the component. Now on the back, we got our little wire sticking up here. So to actually install this, I'm going to bend the leads a little bit. I got to be careful here because this one's going to be near the edge, and if I bend it outwards, I'll get cut because this will be sharp here. So I'm going to bend them both down and then just pull up a little bit because it's going to want to fall down. Actually, what I'll do is I'll bend it out and then I'll bend it back before I solder it, so that the component doesn't fall back down through the board. So we'll do this inner one first. Okay, so this isn't an exact science, but the idea is that you want to heat the component leg and then add the solder so that it flows on the component. So that it makes good solid contact with the board. A garbage can, because I'm going to not make something that's worse than stepping on a Lego would be stepping on one of these. I did yesterday. It's not fun. Okay, it's trimmed and it's installed. So now we have 9 more to go of that particular resistance. Now, the way I am going to do this is that we're going to check our work as we go along. So what we're going to do is we're going to put all the resistors in for the letter S. We'll add both of the diodes in the switch pack, so then that we can pop in our battery and check our work. So that way, if I make a mistake, I should catch it sooner rather than later. Because I can tell you, it is possible to get the solder out of these little holes if you make a mistake, because I did, in fact, rip a bunch of LEDs out on the one I did off camera. And I can tell you for a fact, it is way more fun to put these in than taking them back out again. That I could tell you for a fact. Now, what I had briefly mentioned earlier, that I mentioned that the resistors are a little of a higher wattage than what I needed. Resistors, like a lot of other things in electrical components, need to be rated for the amount of power you plan on putting through the circuit. So, if you have a power requirement of pulling 2 watts worth of electricity through a component, if it's not rated for above 2 watts, or at least at a minimum 2 watts, which that's dangerous playing near the edge of the sun, to be honest, you're risking melting something, or potentially starting a fire, which is also, again, not good. So what we need to do is rate our components not only for the voltage and the resistance, but also for the appropriate power pull. Each LED is going to pull a minuscule amount of power, which means that all I really needed were the 1/4 of a watt resistors, which, for comparison's sake, which I have here. Hang on, let me take them out of the little bag. It'll be a little hard to see what it is. Are these little guys. Now, if we do a quick comparison on size, we can see that the amount of space that they take up in comparison is significantly less. That was simply a snafu on my part, because when I was looking at the catalog of literally thousands of parts to look at, I knew I needed a minimum of a 1/4 of a watt, and I found a part that was 2 watts, which just simply means that this can handle more power than the project will ever require, which is fine. That's its own safety in that regard, because if it can never pull more, if you're never going to push more than what the component can handle, then you've got a safety factor there. Now, something that I also found that's super cool, if any of you are interested in doing this kind of fun on your own time, this is not sponsored in any shape or way, but I found this to be the easiest tool that I found to play with. Is Easy EDA is the name of the application. They have a project board, or community board, where you can look at other projects people have published that you could actually order the boards and buy the components and build the projects that other people have made. I actually didn't know that when I was getting into this, that they actually had a whole community thing, and there's some really cool projects that you can actually get your hands on out there. One of the ones I was looking at, just for giggles, I wasn't actually thinking about ordering it because the ungodly amount of money one would have to spend on it, was an Arduino hat, which means you would take Arduino and you would slot it into this massive project, which with the board and components was like $600 worth of stuff you would require to actually build this yourself. So naturally, I thought, that looks super cool. That's something I'm never going to actually download or order. But I thought it was really cool. So the fact that there's other projects up there, I find really cool. I haven't made up my mind if I'm going to publish this on their whole thing. If anything, I'm going to fix the schematic first if I'm going to publish it, because it's wrong. I know how to fix the mistake because, well, I made the project, and thankfully I didn't make a mistake that was unrecoverable, because as you can imagine, if the traces are already in place, there's not exactly a way to modify it once it's gone to production. Like, you're kind of stuck with what you got. So either you hook things up in a non-standard fashion to make it work, or you add your own traces after the fact, and that's not something I know how to do. So with that in mind, it equates to its own fashion. Now, something I can tell you is that I am blowing that smoke away from my face, because it's not good to breathe in. Which is why, if you follow anybody else that does this kind of stuff, they usually have a little fan that extracts the fumes away from them. I'm gonna be doing that at some point. Just not right now. But you know what? I am so congested as of right now, I don't really think it would even matter. My lungs are like, nah, brah, we got you. You don't even need to be able to breathe in the first place. I'm like, I kind of would like to do that. It's kind of required. But my sinuses have got other plans for today, apparently. have to admit, Chad, I am interested if any of you have ever gotten into anything where you make something custom. Not necessarily this specifically, but if anybody's got any stories they'd like to share, I'd be happy to read them. Yeah, it is fun. Okay, so we now have in place the 9 resistors that are going to protect the letter S in our project here. Before we can pop in the battery to test anything, we need to add the diodes that protect the circuit and the switch pack. So we're going to do those next, and then we're going to jump to the LEDs because we won't be able to test if any of that stuff works before we get those on the board. So we have a switch pack, and then we're going to need ourselves a couple of diodes. Okay. In the name of safety, and again, not looking super close at the part numbers of the things that I purchased, these diodes are capable of handling 3 amps of power when the whole project itself is not going to draw more than 1 across all 3 diodes. So yes, they are overkill. Yes, they are too big for this project, but they're going to work anyway, and they have a safety factor that's higher than anything this project could ever actually risk to achieve. These things are rated, I think, for 400 volts. Yeah, 3 amp, 400 volts. So yeah, our 3.7 amp battery ain't gonna touch it. Now, diodes, like LEDs, do have a polarity, and it is incredibly imperative that we install them in the correct orientation. Or it won't work. So, on our diode is going to be a little barrel in the center, and then on this side, there's a little silver line, which, I'm going to see if I can get this nice and close so you can see it. That indicates the... Was it the positive side? I think that's the positive side. Yes, that's the positive side, because the negative side was when I was testing this earlier. Yeah. So actually, on the silk screen of the board, it does have a little line to indicate the correct orientation to install these in. Because if you do them backwards, boy oh boy, you're gonna have a bad time. Oh, you know what? I need to do the switch back first because I put the part too close. I put it way too close, so if I don't put this on first, there's a risk this will get in the way. They do fit. I know they do, but just to be sure that I don't screw myself anything further than I already have. As I had mentioned, this project was the first of its kind, so it ain't perfect, but neither am I. So you know what? That matches. Okay, so with that, I'm going to put you on there like that. Prop that up. Am I positive? I am positive, yes. I am positive we are going to get there. let me check my work. We got a good spread. The switch pack lifted a very tiny amount, so it's not perfectly flush on the board like I tried to get it, but it's close enough. You can see a little bit of a lift on this side, but again, that's not going to bother anything. The important part is that it doesn't fall out of the board while I'm trying to add solder. Okay, now that we got that situated, now we can handle the big guns here. These things are hella beefy. The legs are so big on this, they do not fit into a standard breadboard because they're so chalky. Because again, it's 3 amps. What on earth would you be doing with a 3 amp component? Oh, I don't know, tech. Maybe ordering parts like a willy-nilly individual because you're making something for the first time. You don't quite know what you're doing, but you know that there's enough safety involved. You know, it's kind of one of those conversations that you have with yourself. Like, can I successfully do this in a way that won't take off my eyebrows? That's kind of the thought process when you're working on something electrical. If I get to keep my eyebrows at the end of the day, I'm working in a positive fashion. Now, with the legs on these being so unbelievably beefy, this is going to require a little bit of effort to heat this up. Now, something to keep in mind is a bit of a dance. Some components do not like the heat of the soldering iron, and if you heat them up for too long, you're going to end up having a disaster on your hands. Because what ends up happening is that you accidentally destroy the component while trying to attach it to the board if it's been on the iron for too long. So you do have to be mindful when you're working with different components. Some take the heat of the iron better than others. And that you just simply have to learn which components do and do not handle the heat well. I can tell you right now that the diodes kind of don't really care all that much, but there are some components that is very much not the case. There you go, that's one very chalky leg. Look at the other one. And then the other thing you got to be careful of, which again, if I were to do this over, I would have been a little bit better with my placement. You see how close that hole is to this leg right here? If I accidentally short these out together, I'm going to damage something. So I do have to be mindful of how much solder I add and how close I am to the neighboring component. That's really hot. I did have to heat that up for a while. Alright, cool. So I installed it appropriately. And now we got 2 more to do. That will not be the last time I handle a hot component. I almost forget that I have an iron set to 650 degrees Fahrenheit, and the display keeps telling me that. It's not like I don't know that. But that doesn't make me any less silly, apparently. Because why would it? Why would I be less silly? Alrighty. Go for our second extra beefy component. These are huge. Hand slipped. That's all right. One of the good things about solder is that if you screw up and you don't heat it enough, just apply more heat and it will flow on the component. You will be amazed how easily you can recover from a pretty bad solder joint by just adding a little more heat. Because that strategy has saved my bacon on multiple occasions. Alright, cool. 2 down, 1 to go. Since the power of the 3 different sections of LEDs flows through these, that's why I'm doing them first. Because if we don't connect these, electrically speaking, the rest of the project won't be connected. That's why it's important that if we want to test as we go along, that I get these in the board now. The trick with getting things like switch flush is solder 2 corners, then check and adjust happily to do the rest of the legs. All right, that's fair. Because what I could have did is I could have just applied a little bit additional pressure. I mean, I'm going to be honest, I could just reheat them and push the switch back down, which I probably am going to do here when I'm done attaching this, just so we can get it flush, because I could just reheat the solder. Those legs are so unbelievably tiny. And I'm not going to run into any issue just reheating that. All right, cool. Let's check out. You are correct. It is one of the more heat-sensitive things that I have, but if I heat up all of them together to push, which side was it? The edge here. I should just be able to pop it back down. You're correct, though, because the switch pack is indeed plastic, so it would be kind of a bad time in America if it moved. It moved down a little bit, and I didn't short the traces out, so that's fine. We'll leave it there. That is the one thing that's at least good, is that this entire project revolves around some pretty high heat, so the chances of the solder reactivating and melting off the board is next to slim to none, unless you drop the thing into like a campfire or something. Like if this project was in your car, it'd be fine. Yeah, unless it was Texas, then your results may vary. Texas is the face of the sun. Or neighbors to the face of the sun, as I've been told. I have friends in Texas. Texas is also the face of the sun. You could also drive 6 hours in Texas and still be in Texas. So, not only is it a toasty state, it's a long boy. So there's that. Alright, so that should be 9. We have there. Okay, so things don't tend to unsolder themselves unless you have a particularly bad day, like nuclear fallout. That generally tends to chalk up to be a bad day. I feel like we get closer to that every day, but you know, we keep ourselves positive. Now, something I'm going to do here before I just blindly solder the LEDs into the project is I'm going to check to make sure the LED is functional before I do so. These come in a bag, and there's chances of them being duds. So a really easy way to quickly check to make sure your LED is good is to test it with one of these button cell batteries that are 3 volts. Just briefly tapping it on the battery like that to indicate that it's functional is all I need to do to make sure it works. Oh yeah, and check polarity. You are correct. Any component can be emitting for a time. Yes, exactly. And any machine can be a smoke machine if you operate it bad enough. Okay, so our LEDs are polarized. They have a polarity. The longer leg is the positive, and the shorter leg is the negative. Now, 3/4 of this project is correct in which hole you put things in. There's the positive and negative markers on here, but we're gonna have to ignore that for the H and the E because I made a mistake. So I'm gonna put the long leg through the hole of the S, like so. We'll place it in there like that. And then I'm gonna bend the legs and we're gonna add a little solder. Okay, beautiful. The legs are incredibly small on these, so it's going to take next to nothing to add the solder. Okay, so at this point, we've got the nine protection resistors in place that protects this section of the circuit. The rest of the board is electrically connected to the grounding terminal, which is down here, which means if I put the battery in right now, which we have right here, and we toggle on the second switch, we're going to get light. And we do, which means everything I've done up until this point seems to be working. And that's just the second switch that's turned on right now because that's the one that's going to control our S. So I can toggle that back off and away we go. Now, in between attempts of checking to make sure I do things correctly, I am going to be removing the battery because I am working with a lithium-ion battery. Those do not take kindly to heat, and the last thing I want to do is put a very hot soldering iron that's capable of sending that battery into thermal overload and removing my eyebrows. I'm going to keep it away. I don't want it in the project board for safety purposes. So, now that we've got that out of the way, we're going to check and proceed to install the rest of them. Okay, that one's good. Now, of course, you may be wondering, well, Tech, if you check the LEDs to make sure they work, why didn't you do the same with the other things? Well, that's a valid question, and the answer I'm going to give you is that my multimeter is broken. And the things that I would normally show you that you could use to check those components, I can't do right now. But if I had a functioning multimeter and I felt like I had a bad resistor, well, then what I would do is set my multimeter to the resistance mode and actually check the resistance of the resistor. That's an easy way to make sure the component is functioning as intended. I can't do that right now. Because it decided to die when I put the camera on it for whatever reason. I did put fresh batteries in it, but it's still acting either dead, where the screen doesn't want to come on, or where it just beeps endlessly as if it's got an internal short. Which I can admit to you is less than convenient because I was going to use it this evening, but that's okay. I may have had that particular thing for quite a decent amount of time, but it's cheap enough to replace. So I'm not going to dwell on it. I'm just going to move on. And we're going to continue to build this fun little project I've brought before us here. Now, an additional word on safety when it comes to this particular project is that I have the 3 diodes to protect from reverse polarity. But you'll also notice that this particular project does not have a charging circuit. It's got a removable battery. Why does it have a removable battery? Well, because I don't have the knowledge to build a charging circuit that would behave safely right now. So instead of making this project potentially dangerous, I decided to make the battery removable so that the battery could be charged in an appropriate commercially created charger that will safely charge the battery. And I'm using protected batteries, which means there's a button top on here with a protection circuit, which means that if the battery goes too low, the battery shuts itself off to protect itself from damage. It won't undervolt itself, it will turn off. That means I can't cause battery failure, as long as the protection circuit works as intended with the battery. Because the fun fact about lithium-ion batteries is that if you overcharge them, they blow up, and if you undercharge them, they blow up. Or technically that's discharge them, not charge them. But yes, you can experience battery failure of the not good kind if you go too far out of range in either direction. As far as I understand, the more dangerous is the overcharge. If you put too much voltage into them, that's usually what causes the battery to go boom, or vent, as it's usually called. Because these types of batteries, underneath this little protective plastic cap, is a vent that's hidden in here. So that if this battery were to be shorted out, the protection circuit couldn't prevent bad things from happening. It's going to vent very violently flammable gas out of the top of this in an event to protect the user from further damage. Because if you can have explosive gases thrusted upon you in an inconvenient manner, like as if the battery was in like your pocket, for example, because your car keys shorted out the leads, which again, this is why these types of batteries come with carrying cases, that at least means that you're going to be mildly flammable for a couple of moments, but hopefully as long as there's no additional sparks involved, you're not going to catch on fire. The reality of the safety of these types of batteries, I feel like really needs to be expressed a little bit more, because they're safe to a point, but they can be dangerous in the wrong circumstance, which is why we just have to be careful if we're making something to make it so it's safe. Nothing is going to be perfect, but that doesn't mean we shouldn't try to make sure that what we're building is safe. Now, since this thing is kind of big, I'm thinking about making some kind of thing to put it in, which I don't really know what that's going to look like, but I did purposely ask for a couple of holes to be made in the board so that it either could be hung like on like a paper clip, or attached to a thin piece of string, something like that. Something that's more or less non-conductive, but those holes are not conductive regardless. But I haven't quite come to the conclusion on what that's going to look like. But I figured this is something that could sit on a desk. So I figured maybe something that can hold it up, kind of like a phone stand. But I don't have necessarily any plans on that right now, other than I was thinking about it. In a project like this, there will probably come some kind of revision on what's going to hold it so it doesn't lay flat on its face. But as any good project, those kind of things come in due time. Doesn't mean the reality is, as much as I enjoyed the 3 Days in Space franchise, I like the idea of making things myself even more. But as any good project, there always has to be some research involved, because if you throw things all willy-nilly without checking best practices, you get end up with something that simply doesn't work. That's something that could potentially be less than ideal. So that's why we do our research. I can express that till I'm blue in the face, because I know I've said it on this channel before, and I'm going to say it again. Do your research. This is a project I've done a decent amount of research into. Okay, that's good. Okay. Now with all those in there, we have our first letter, the S, which is beauteous. Now, I think what we're going to do is we're going to put the rest of the resistors on the board, just so that's built out, and then we'll build the H and the E because they're reverse polarity, and then the finish with the T and Y and they. I think that's the orientation we'll run this in. Now, as I had mentioned that my resistors are a little bit bigger than they probably should have been, because again, needed about the 1/4 of a watt rated, and I got 2 watt. This is why we check our math. Because these little dudes at least fit flush in the board at their rating of, where did I put those? I want to say these were 2 watt, but were they 2 watt? Yeah, these are 2 watt. 2 watt 100 amp, or 2 watt 100 ohm. These are also 2 watt, but they're 47 ohm, and for whatever reason, they are ungodly large. So they do fit through the holes on the board, but they do not sit flush on the board. So they're going to stick up at a slightly awkward angle. But again, that also leads back into the whole learning experience thing, because I can tell you right now, I did not anticipate components not quite fitting. Pablo Blues 21, thank you for the follow. Welcome on in. I am TechN41. I do silly things like this on the internet. All right, so as we can see here, as I get closer, we don't fit. So what I'm gonna do is I'm gonna drop this edge and lead them back up a little bit. That leaves a bit of an open location for a point of contact to hit it with a multimeter, because that leg is really long, but that's the way we're going to leave it when it's installed, so that it sits kind of at a bit of an angle. My camera would focus, that'd be nice. There we go. But yeah, so that's how that's going to go in there. That way they're at least secured, but in a way that is kind of out of the way. I've got majority of the resistors in this project are the 47 ohm ones. So not only did I make a got a bit of a boo-boo, I made a big one because there's so many of them. But just like anything else, it's a learning experience. And I can tell you right now, I have learned a lot from making this project from start to finish. Um, I'm not going to say that doing the math was anything really difficult, but just finding the right information in a way that makes sense to you, I think is probably the most difficult part of this. Because I found plenty of technical articles that explain a lot of what I'm doing here today, but it wasn't in a way that I really understood well. I can look at some technical documentation and at least have a rough idea of what I'm doing if it's something complicated like a spec sheet. Because there is tons of very confusing mumbo jumbo language that comes with a lot of the technical documents that would not only bore all of us but lull some of us unconscious. They're just not easy to understand. So looking for someone who explained this in a fashion that I understood, and more importantly, not only understood myself, but in a way that I understood that I could put it in my own words, that's what I really needed. Because not only do I want to express to you why I'm doing what I'm doing, if I can't explain something in my own words, then I don't understand it enough. That doesn't necessarily mean I have to explain it well to understand it enough in my own words, but if I can't tell you something in a non-technical fashion, then I don't know enough about the subject. And that is a really easy way to point out if someone really knows their stuff or not. Now, granted, not everybody is great at explaining things to people, and that's also a learned skill over time, but I find that a lot of people who talk about technology, that if they can put it in their own words, they're usually pretty good on the subject. But I also don't like being left in the dark and not understanding something that's going on, especially if it's something I'm working on. Because sometimes it's just a couple of details that makes all the difference. But that's okay. But unfortunately, yes, this is one of the drawbacks of putting all of these LEDs in parallel. I have to have so many resistors in the board. And of course, I didn't get small ones, so the board's ginormous. I mean, the initial idea of this was going to be something more of the size of a name tag. This is a very large name tag. Oh, and yes, I did actually draw the board dimensions in that program, by the way. It did not auto-generate that. So I can tell you that not only did I know it was going to be this big, I made it this big. I probably should have paid closer attention to the dimensions I chose. But you know, when you're toying with something, how closely are you really looking at the details? Hopefully close enough that it works. That's pretty much what that boils down to. Harder to miss. You're not wrong. I mean, that's a good point. If I am using this as a show and tell piece, those components are absolutely ginormous. You'd have to have eyesight as bad as mine to miss those. Granted, I'm not picking on myself. It's
it's something that I noticed when going through the process. That's solder hole on the side a little bit, but that's alright. It's far enough away from the components, it's not going to bother anything. One of the things that is kind of fun, though, is that the solder will flow. Excuse me, will flow back and forth between the different sides of the board, depending on the angle of your iron. So I slightly changed my angle there a little bit. That actually caused the solder to flow back up to the other side of the board, so that now that the component has that little solder ball right there, but it's far enough away from everything, it's not going to bother anything. Because when I had discovered that I had messed up the polarity on two of the letters, I had to get all those holes reopened up so that I could actually put fresh solder over it. And what I had discovered before I burned my desk mat is that if you push the solder iron where the component is through the hole after you've got the component out, the solder will pool on the back of the board. Gravity doesn't affect it, it just stays there. Because I had the board like in a 90-degree angle, holding it like this, pushing the iron from this side, and then the solder just balled up on this side, and then I just used a little, it's similar to a turkey baster. It's a little bulb that you could just use to suck up the solder, and surprisingly, the liquid solder doesn't melt the rubber bulb of that tool that's used for removing solder. It's actually really cool though, because if you do end up getting a little solder stuck in the nozzle, you just take a paper clip and you just push the solder right through into the bulb and just empty it out. Think of it like a hole punch, and then like you just empty the hole punch reservoir every once in a while. It's that same kind of concept. Something cool that I did come across though in my travels of learning what I needed to for this project was a car forum that was actually talking about the resistors and their actual physical size of the resistors from today compared to resistors of like the 50s and 60s cars that were on the road. There was one forum I was reading that they were rebuilding a car and they had some burnt up resistors that they needed to replace. Well, through the service manual and what they could figure out from the documentation that they had, they figured out what the resistance of the component was supposed to be. But here's something that was kind of interesting, though, is that when they found the comparable replacement for the appropriate resistance and wattage of the component, they had noticed that the part that they ordered was physically smaller than the original one that was in the vehicle. So much so that they thought they had actually gotten the wrong component from the manufacturer. So it turns out the technology that we use to make resistors has actually changed since the 50s and 60s. So much so because manufacturers know that everybody needs smaller components to make the things that we carry around with us every day be smaller. So a 2-watt, 47 ohm resistor such as this is physically smaller than the ones from back in the day. And that's just because technology has advanced and components have actually gotten smaller. Even though this is just an individual component in the bigger project, the fact that the physical pieces have gotten smaller over time is still accurate. Now, granted, there are like the really small ones, like SMC components, which are like the size of like a piece of your fingernail. They're like super small. As you can tell, I've gotten the through-hole component size style because I don't quite have the tools to work on those types of components. And that's okay. As someone who does this as a hobby, I might get into that at some point, but it is a definitely an involved process that requires a lot of skill, a lot of attention, and you're working with some really small things. So placement is incredibly important to make sure you get it right the first time. Because fixing a bad SMC solder, ugh. So I'm working with wire solder right now, which is this roll of lead-free solder. When you're working with those super ultra tiny components, you don't solder things on the board this way because they're so small. Your level of control is just not the same. So then that means, how do we actually solder really tiny components? Well, if you're doing it as a manufacturing plant, what you do is you take the components and you run them through a very specialized machine that places the components and then very precisely lays the solder as a paste, and then the paste gets heated, and then all the components get baked into their appropriate location, which then keeps them where they need to be. Or, if you're someone who's doing this at home, you're still going to use the paste, but as an individual, you're going to use something called a silkscreen that you actually place over the board before you lay the components. You lay the paste out on the board, you swipe it, and then remove the stencil. And then you lay your components over all the areas where the paste was stuck. You then take that and place it on a heating element or a heated bed that you actually will use to heat the board and solidify your components in place. Or at least that's the way my research explained it to me, because I was looking at that, and it doesn't seem impossible, but my level of skill right now is putting things through holes and soldering them with a big hunk of wire. So I know where my skill set is, and I'm staying with it for the time being. That's not to say that I might not look into it, but I figured that I know how to do this, so if I'm going to make something custom, why not build off of what I already know? Because there's nothing wrong with taking on a project with a lot of unknowns, but if you have too many unknowns in your project, you have to figure them out on the fly, well, that introduces a higher chance of things not really going as intended. And if enough things don't go according to plan, well, then it doesn't work out, right? So by building on the skills I already had, it got me to where we are. And when you're learning anything new, build on what you have and go from there. not to say don't take a plunge on just trying out something completely random that you've never done before, but set reasonable expectations for yourself. Because then you've learned something. And even if it doesn't necessarily work out, you still don't have to be disappointed. I don't know. That's my take on this kind of stuff, because anything that involves a lot of unknown requires a decent amount of research. Hey, it's almost like I said that before, because I won't stop saying it. But it's true. It's true, because if you don't work that into what you're doing, then it's a pretty easy way to burn yourself. I mean, I can easily burn myself, but I'm talking about the different kind of burn, not the solder iron kind. Yeah, we're getting there, though. We got most of the bottom row filled out. One thing I can tell you, though, over the course of some of the research I've done, is taking the microcontroller that is used in the Hero and Arduino boards and retrofitting the components you require to take a project like that and just make it that a part of your board is surprisingly not that many components other than the Arduino chip itself. The Arduino chip itself does require a clock, a crystal clock, which is a fairly cheap component. That's what it allows you to use it to keep time. Excuse me. And the there's that and a couple of resistors and a couple of capacitors that make that board function before you add your things. So thankfully, not only is it an open source developmental platform, there's a decent amount of documentation on how to actually take something that you've built on your breadboard that you've been plugging into your Arduino, but to be able to take the entire project and stick it on one board. Which is awesome, because if you're going to make your own thing, it would be great to be able to put everything onto your custom board. Because an Arduino takes up a decent amount of space, so why have an extra board if you don't need to? Now, granted, what I did here by ordering these isn't necessarily a requirement if you want something that's more permanent. There are boards that come with a layout very similar to a breadboard that you can buy, that you can just connect your components to and solder them in place wherever you want. So you're the one building the traces that actually like make the project work. But that then doesn't require you to have to speak to a manufacturer to get it made. Now, granted, you don't get the nice silk screening and all this, the little diagram that you put together that you also again do yourself. So it's a little bit more open-ended if you do it that way, but you can save yourself money and time by just building the board yourself, if it fits within your own parameters, which is also cool. Again, I apologize for all the coughing I'm doing. I'm trying. I have to admit, I'm a little lucky though, because the spacing on the resistors, they do fit, but let me tell you, boy, is it a tight fit. They're really close to each other on the positive side of the board. Alright, so we got those in there. We're gonna rock these guys up here. I can admit I partially regret sticking these two resistors up here between the H. Like they're kind of in the way up here. I was trying to save space. I was trying to save space in the layout, but it's as big as the board is. I could have put the layer anywhere else. It doesn't affect anything, it's just my preference, really. I feel like I'm sounding like some of the artists that are just like, this is my work, but it's not good. And then you're like, no, it is good. Frankly, it's amazing. And they're like, no, it's not good for all these reasons. And we're like, no, not really. I feel like I'm doing that same thing. I have several artist friends that we go back and forth with that. And I am happy they're not here right now because they'd probably be telling me the same thing. And I'd be like, no, but you. Okay, let's see here. But I suppose as someone who makes things, I tend to look at the flaws. I try not to. Oh good, we're almost there. Alright, we have this last row, and then we get to go back to doing LED stuff. This is easily the most time-consuming part of this process. Are all these resistors. And frankly, without my multimeter, there's no way to really check them. So we're just gonna do the thing called trusting the process. Almost got it. There we are. Yeah, it's more like it. I like I like the component has like a slight click to it when I see at the bottom. It's very satisfying. This. Yeah, the thing I am looking for, though, why I hit these more than once with heat, is that the ball of solder actually flows down the component leg. Because if it doesn't flow, then it's called a cold solder joint, and it doesn't really pass electricity well. Which is why I keep hitting them back so that the solder flows onto the pad. Once it's on the pad, then we good. So that's why I am doing that, by the way. I mean, it's probably a little hard to see I'm doing that, but if you're noticing the fact that I'm going back to each leg more than once, that's why I'm doing that. So if I don't see the solder flow downwards, then we got problem. All right, that is all of the resistors that we need to put on this board, which means the remainder of this I'm going to put back in its bag. I'm gonna keep everything neat and semi-tidy. One of the things I did pick up though is a components container, so I can actually organize the stuff outside of the bag. As you can imagine, tiny things are probably, you know, a little difficult to organize when it's so damn small. Okay, so techie that had a multimeter want to put the battery in to show you that we now have voltage across every one of these leads where the LEDs go. But techie who doesn't have one of those is just going to point out that fact. If I put the battery in and I flip these switches on, we're going to have active voltage across all of those, even though we don't have the components in yet. Now, to prove that I didn't damage anything in the process of getting us to this point, I'm just going to quickly pop the battery back in and see if the letter S still lights up. So that's good. I didn't anticipate breaking anything because I only touched the stuff I needed to. Now we are going to work on the letters H and E. Now, normally the polarity would be correct on the board, but as I have expressed a couple of times, it's backwards because I made a mistake. That's okay. That just means that I have to mentally prepare myself to put these in backwards. So the positive lead is the longer one, and I'm going to put that in the location of the negative because it's backwards. Now again, the spacing is exactly the same. If you're looking at this board after it was built after the fact, what you would notice though is that you see how there's this flat spot on the edge of the components, like the LEDs aren't perfectly round. That's the fun fact. LEDs are not perfectly round. There is a flat spot on there to indicate to you that the flat spot is the negative lead and the rounded side is the positive lead. So if you've already cut these and they're shorter, that is a really easy way to note which leg is which without having to apply power to the part. Because if you didn't have this little button cell battery like I do, that's an easy way to be able to figure that out. Now these components are factory fresh, so naturally that's why we're good there. But just to show you now that I did put that in backwards, and I turned that on, we got light. So as promised, the diagram is backwards, but that's okay. We've noted it. I'm just grateful that it's a simple mistake that I just had to spin a component around to fix. Because once these are made, you kind of can't really do anything to them. You kind of have to just either use them or throw them away. Oh, and something else I didn't mention that I'm going to show you after I cut these. Because the LEDs have polarity to them, that's actually noted on the board by the holes on the board. The pads are circles and squares. So the square indicates the negative and the round indicates the positive. I'm sorry, I'm reading that backwards. The square is the positive and the negative is the round when it's wired correctly. So if for some reason you couldn't make out, or if there wasn't a diagram on the top side, if there was no silk screen or you couldn't make it out, that is an easy way to determine what that's all about. So, so thankfully there are some hints in all of this. You're not, left completely to your device pun intended, there is some markings and notes that do stick with the board, thankfully. So you're not completely flying blind, as it kind of feels like you are. We're working on something like this. Yeah. Mm-mm. But here, you know, we completed the H. Let's check it, make sure it lights up. Yeah, that is bright. Alright, cool. Keep on going. And then the letter E is also reverse polarity, and then the rest of it will be as it should be. The T and the Y are going to have a proper polarity. And since the trace legs are exactly the same, the project doesn't know nor care that I'm not following what's on the actual silk screen. That's more or less just reference for the rest of us. Oops. This accidental trim. The beauty of it sometimes not being completely flush is the garbage can. I can cut this over. This might come as a surprise to you, but when you cut these little things, they kind of want to fly across the room. So visual protection to protect your eyeballs is highly recommended when working on this kind of stuff, especially when you're cutting the legs off of components. Because let me tell you, you ever work with a leaf spring before? And once like the tension of it is gone, it like wants to just send it. That's pretty much what these little things do when you cut them with the cutters. Alright, oh, I am done with all the green. Alright, cool. So, with all those, I can put that up, and then we'll pop our battery in, and we'll be sure that I didn't goof any of those. Yep, that's good. So we have she. We'll have the letter S on right now. And if I toggle that off, we've got E. So, coming along, so then for they, we need the T and the Y. And as I mentioned previously, we're going to do that in white LEDs. It will do the same thing as before. We'll check them before we install them. And now we're back to the legit rule. Gotta take the battery out. Yeah, gotta follow the rule of the longer lead going through the hole with the positive now. So now we're switched back and doing it this way. And I am gonna check this one just to make sure everything lines up before I do the whole letter. I've already done one of these off camera, so I know this is the right way, but when you work with a bunch of individual components, it never hurts to double check. As I can tell you right now, reflowing the solder to take components off and put them back on is a major pain in the butt. It really is. Because you can reuse a component once you cut the legs off, but it's so much more difficult to work with. Like, by like a lot. Okay. We're ready for launch. It's funny because I have to say that out loud for both you and me, because when it switches like that, like if I don't say it out loud, like I have to materialize the fact that I'm doing something against the way you're supposed to, and then flipping back to the way I'm supposed to do it. So like if I don't say it out loud, I'm not materializing it. I have to wonder how many other projects like this, as simple as this one is, it's just LEDs and resistors, like have gone to production with a mistake like that, and then like you just have to know as the assembler, hey, this isn't quite right, do it this way instead. Like, I really have to wonder how often that actually happens in a production environment. I'm imagining it's probably more common than we probably think, because it's just the fact of how many moving parts with how many tiny components you have. Like, it feels like a pretty big blunder to mess up traces, but As a first project, it's fine, but it does make me wonder though. Especially as a project that would involve multiple people. Like if you're doing this for like your job, if you're like making actual things that people are going to use, like that. I feel like there's a decent amount of testing that needs to go into it to make sure that, you know, things work at least most of the time. I mean, there's plenty of instances where that hasn't worked out, but I'm not going to pick on any of them in particular because it's not my place to. Tip off. Oh, come on. There we are. Oh, I'm hearing sounds. Ven X? I'm hoping I've said that right. I'm sorry, your name just appeared so far away from me. Hello! Thank you for the follow. I am TechHead41. I do silly things on the internet. I play games. I play with technology. I talk to all you lovely beings. This is a new one for me, making things. I enjoy making things now. Next, I'm curious, have you ever made anything custom? I'm not even talking about specifically the electronic space, just in general. I love hearing about people's personal projects when they make something cool. That's why I feel like the content creator Mark Rober is so popular, because he does some cool stuff on a really large scale. I think my favorite thing that he did as of recent would have to be the obstacle course for the squirrels in his backyard that he put together. But I mean, the man said that he worked for NASA, so I mean, you got the smarts and you're willing to have some fun with it, well, why not, right? If you're not having fun with it, I don't care what you're doing it wrong. Chad, I am going to warn you, when we test the white lights, they are incredibly bright. So if you are watching the camera, try not to blind yourself, because this is going to be flashbang worthy. Especially when I turn off the lights to show you the finished product. I will give you a warning, though, before I do that, because I don't want to blind nobody in chat. As someone who's in the same room, I'm going to be able to show you that the light bleeds through the back of the board with this on. Like, it's no joke. It's bright. I kind of really awkward angle with that pin. Let's do this one first. Come on, honey. There we go. I bet this leg in a very not great way, so it's kind of hard to eat. Oh, I did it again. I cut two legs at once. That's another reason also, by the way, as to why I'm removing power when I'm between takes of checking, because I'm actively messing with all the circuitry on the back. And if one of those legs shorts out across multiple legs, I'm going to probably burn out a component. And I'd really rather not do that if I can help it. That would be what we call the ideal solution, is to not do that. Honor Lover Femboy Twins? I don't know if that was plural, that went by too fast. Thank you for the follow, welcome on in. I am very slowly building together this project. I see a lurk. Hi, minion. Very lurk. Oh no. Dipsy, EP, and floof-headed and heading to bed. That is valid. My word. You got some good sleep, minion. It's good to see you. I'm not necessarily sure what's keeping me going at this time. Yeah, 4 a.m. I figured it was probably pretty late for you. I love them time zones, you know? For me, it's on the precipice of becoming late. But I guess that's technically tomorrow, like early tomorrow. But if you don't go to bed, is it really late? Or at what point do you consider it no longer late, but just really early? For me, anything beyond 1 a.m. is just really early. But again, that's me. I forgot. I flashbanged myself. All right, good. That works. I am seeing dots now. Oh, a birthday party. Ooh. Well, from all of us in chat to your special being, I wish them a happy birthday. That's always a good time.
I guess we all have future pants. They're pants we're going to wear tomorrow. And the next day.
3 a.m. still counts as really late. 4 is really early. Yeah, I mean, that's fair. I don't know. I mean, the internet says that anything beyond midnight is considered morning, but it doesn't feel like it, because you've been up the entire time. I don't know. Time is weird. Time zones are even weirder.
And the day after that. I guess we all have future pants. They're pants we're going to wear
Okay, we're almost there. We got a couple left.
the next day. And the day after that. And the day after that.
All right. We have reached the end of that assembly. Now, check. Content warning, this is going to be bright. So T and Y are functional. Okay, let me hit the lights and we're going to do a little demo in the dark. I say that as I am looking for my phone that is currently sitting in front of me. That's okay. Just a second. Okay, there we go. Now it's dark. About as dark as I'm going to be able to get it. Okay, so with our switch pack, we're going to turn on the first one. That is going to give us the H and the E. Now, I do realize this is going to overpower the camera a bit. So I'm gonna move this closer. That should help the focus. Or actually, you know what? Hang on. Let me zoom the scene in. Maybe that might help correct it because the the bloom on the frame is really bright. If it's gonna listen, I don't know if it's gonna listen. Unless I've got the wrong camera selected. That might be a problem. All right, hang on, I'll do it manually. Let's see here. Oh, that's not what I want. It's this one. It's not going to listen. That's fine. It's number one. That's what manual zoom is for. Alright, we're going to let this abomination see if this will focus. If not, I'll lift up the camera and see if that potentially helps us out here. And the answer seems to be no. Okay, that's fine. Fun that that preset works. Did this one get reset? Alright, it's fine. Apparently that got reset. I'll fix that later. That's not a big deal. Okay. Yeah, if I manually move this closer. So here, there you go. If I hold it at an angle, it's not washed out. Okay, cool. So we have he with switch 1 enabled. And if I toggle switch 2, we get she, right? Now, I mentioned this is bright. That's how bright it is. You can actually see the light coming through the back of the board. And then, last but not least, we'll turn off the S and enable the T and the Y, giving us they. And again, so unbelievably bright, you can see it through the back of the board. And as advertised, as I had mentioned, if you do toggle all of them, it does let you do it. It's not going to be bothered. It's just, it doesn't say anything. Shut up. But yeah, so that is a super cool thing that does work as anticipated, which is fantastic, because that definitely took a little bit of finagling to get working. That bag of LEDs under there. I love that the Y is so unbelievably bright that it still washes out the camera. Like, it's not going down without a fight. It's almost like that angle almost isn't even steep enough to be able to actually read it. But if I turn on the room lights, that should help with the washout. And it does, significantly. So, yeah, that helps. Alright, let me get our standard lighting back on here. Alright, cool. I can see stuff again now. That does indeed come in handy. No, Pine, more, how many more resistors do you want? Oh my word, needs more resistors. Like most of the project is resistors. Yeah, as I had mentioned, I didn't do one of these ahead of time. So there's the other one I pre-built. I didn't want to show this without like us going through the process because I wanted you to see it as it came about. Because it's easy enough to show the finished product, but it's a different thing to be brought along for the way. And actually, the back of this is sharp because, you know, traces. So one has to be careful when you set this down that you don't scratch the surface. Which is why I got to see if I can come together with some kind of enclosure to slide this into. I don't know. I haven't figured that part out yet, but I'm sure that will come in due time. Because I would, I would like to make some kind of stand for it, but I don't quite know just yet what that will look like. Because I think my end goal would be to make it so like it can like lean, you know. Well, thank you, Vine. I appreciate that. It does feel nice to finish the project, and more importantly, that it, you know, works. That does help a bunch. I mean, I can't tell you for a fact that if I did permanently ruin the letters H and E in this project and the rest worked, I still would have been happy, just not obviously as content as finishing the project with it all working. But naturally, that is the nature of the beast when you make something yourself.
So that's okay. Out of curiosity, does anybody have any questions on what I presented this evening? I am curious if any of you have any thoughts in closing here, because I I could expand on any of those concepts if we need to. Okay, cool. Is my mouse gonna work? I feel like my mouse should work. Alright, cool. Alright, cool. We're gonna swing over to Cad Pig JR. This individual is big in VR chat, and in this case is playing Final Fantasy right now. They're very delightful, and I would like us to all go say hello before we all disperse for the evening. So I appreciate all of you swinging by to see this. This is a really successful project. I mean, multimeter aside, but yeah, it's fine. This was fun. Like I said, I do plan on doing more of these kind of things in the future, potentially less sick. That would be good. I am sorry about the sound, but face, you know, that's how that works. I can only refresh this visor so many times. Yeah. So with that, I wish you all a pleasant time zone. Bye-bye.